Hi, my name is Erica Castillo. I am an undergraduate student working on a wireless sensor skin project sponsored by the NSF. We are studying the sensor skin for crack detections in airplanes, bridges, etc. The major advantages of the wireless sensor are that they can be wirelessly interrogated and no external power source is required. And most importantly, these sensors can be used in the form of arrays as shown in the picture. Next, I will show you how easy it is to fabricate the sensor skin on an aluminum specimen. First, we need a metal plate to serve as a ground plane. To ensure good bonding with other components of the sensor, the metal plate is polished. We typically use sandpaper with 220, 400, and 600 grades. Polish for about 30 minutes. After polishing, the surface should feel smooth. Next, 300 FN 929 Captain is glued to the metal plate. Captain serves as a substrate between the ground plane and the antenna patch. A weight can also be placed on top of the Captain to obtain an even distribution of the glue. You may also use acetone to clean the edges and holes of any excess glue. Once the Captain is bonded to the metal plate, the laser fabricated antenna patch is superglued onto the Captain. Before gluing the Captain to the antenna patch, slightly polish the antenna and Captain surfaces with 600 grade sandpaper for good bonding. After light polishing, distribute superglue on the entire patch, including the strip, and glue it down to the Captain. Next, we work with the PHEMT, which serves as our FET device. When handling the PHEMT, it is important to use the wristband, since the PHEMT is sensitive to the static charge. Using the wristband will remove any charge you might be carrying with you. Place the PHEMT terminals as shown. Proceed to outline a rectangle on the Captain with the cutter around the source terminal of the PHEMT. Cut the rectangle piece of the Captain and scratch this area with the cutter. Also, cut the additional source terminal with the scissors. Now we will connect the PHEMT. Put a small amount of conductive epoxy mix between the PHEMT source terminal and the square region on the metal plate. This will ground the source terminal. Leave this on the heating plate for 15 minutes at 60 degrees Fahrenheit. The next step is to add the photocell in order to obtain a light-activated microwave switch. Glue the photocell down with the superglue. 560 kilo ohm resistor is used in the circuit. The resistor wires are cut on both sides to obtain a workable length for the antenna sensor. Once this is done, the wires are bent so that the connection can be made between the photocell's terminals. Next, proceed to apply conductive epoxy at the three following locations: strip line and drain terminal of the PHMT, at the gate terminal of the PHMT, cathode of the photocell and resistor, and last at the anode of the photocell, resistor, and source terminal. Be very careful when handling the conductive epoxy, as it can get all over the place very easily. Place over the heating plate at 65 degrees Fahrenheit for 20 minutes. This completes the antenna sensor fabrication process.